I'm Jack Vallely,
I'm Campbell Mockler.
and this is our research methods Resub.
Validity is described by Tenenbaum and Driscoll as something that suits its purpose.
There are three types of validity: internal, external, and face validity.
Internal validity relates to the conditions of the study and how well the experiment serves its purpose.
In sports science, an example of something with a high internal validity is a 30-metre sprint test, because it tests someone's speed, because it is essentially how fast they can run 30 metres.
Internal validity is useful when testing, as it tells you whether the test has worked at the end.
External validity is defined by Williams and Ragg as the extent to which results of a test apply to the outside world.
An example of external validity in sport would be mental relaxation in a snooker player. For example, when they're going to take a difficult shot that puts a lot of pressure on them, the outside relaxation techniques can keep them from looking at the outside world and what's going on around them, so they can focus on their job and what they need to do.
This can also be used outside of sport if they're in their life outside of sport, and if they ever get annoyed or agitated, they can use these relaxation techniques outside of the test scenario. And finally, external validity is just essentially if the test works in the outside world.
Face validity is how relevant something is to the purpose that is being served, that is supposed to serve. Sorry.
For example, when you're testing power, the vertical jump test has high face validity because it tests the explosive power, which is a combination of speed and strength in the person's lower leg, which is exactly what you need for this test.
Face validity is important when testing because at the end of the test, when you have your results, it shows the assessor if it is measured what it is supposed to do.
Reliability is the study of error or score variance, so it's essentially just how consistent a test is.
In short, reliability is concerned with the consistency of a test or other measuring device.
A reliable test is something that can be consistently used and it will come up with good results every time. So the sit and reach test to test flexibility is a good test because it tests the flexibility in the person's lower legs and upper legs and back. So it's a good test for flexibility because it tests the range of movement in these areas.
On the other hand, an unreliable test in sport would be testing the 100-metre sprint with a basic stopwatch, as there's very much room for human error, such as stopping a stopwatch too early or too late.
Accuracy is defined by Gledhill as the quality of the result.
An example of accuracy in sports would be when carrying out a test in a lab compared to carrying out a test in a field, as there is less room for error in it. It cancels out a lot of opportunity for human error, as where there would be in field, as it's tested by an assessor rather than
and equipment. It is important to consider the accuracy of results, as it is crucial to whether a test should be used, because if it's not accurate, the test is incorrect.
Precision can be described as the quality, condition or fact of being exact and accurate when testing.
Precision is important because it also relates to the reliability of a test, because precision is based on consistency, if it is the same over and over again. So a good test that could potentially be used is body composition, because if it is if the person doing it is reliable, that means you will get consistent results on each site.
An example of precision in sport would be in football in training, when a striker is practicing penalties and they're aiming for the same spot and hitting the same spot every time without fail.
So low accuracy, low precision. As the diagram shows, this is an example of low accuracy, low precision, as the person is not hitting the target.
It is important to notice whether a test has low accuracy and low precision, because at the end of it, the results might not be correct and accurate in what you need.
So essentially, they're not hitting the target they want, and it's very scattered results.
Low accuracy, high precision can be seen in this diagram, and an example of low accuracy, high precision is when a hockey player is aiming for the top left in the goal, but is constantly hitting the bottom right. It's not accurate as they're not hitting their spot, but it is precise as they're hitting the same spot even though they're not meaning to.
An example of low accuracy, high precision could potentially be the incorrect use of a blood pressure monitor, as it may not be accurate, but you'll be getting similar results every time.
High accuracy, low precision, as shown in this diagram here, could be when an NFL kicker is kicking a field goal, and they're getting the ball in the zone every time, but they're not hitting precise spots.
An example of a test in sports science where this could be apparent is when measuring someone's waist to hip ratio, because the test may be accurate, but over the multiple times that you test each area, you might get a variable of results.
High accuracy, high precision. An example of high accuracy, high precision could be a basketball player shooting 100% from the field throughout a whole game, as every single one of their shots goes in and where they want it to go.
An example in sports science of an environment that would have high accuracy, high precision is the lab test environment. This is because you're using very precise equipment that will test exactly the person's results, but it will also be very accurate as well and consistent. And this is just our reference page for this.